Okay, let's look at the practice exam 3, problem number 5. Right, so we want to find the absolute max and the absolute min of this given function. Right, so first thing we do is take the derivative and to find the critical numbers. Right, so derivative. So f prime of x is equal to, right? So we have to take the derivative of this, but you notice that it's a product of two things, multiplication. So we're going to have to use a product rule. So that's the first guy, x minus 2. Second guy is quantity x plus 1 squared, right? By product rule, derivative of the first, which is 1, times second, so quantity x plus 1 squared, plus first guy, quantity x minus 2, times, right, derivative of the second guy. So put the power in front, so 2 in front, and keep the same quantity x plus 1. Raise it to the first power because 2 minus 1 is 1, right? Then multiply by derivative inside, which happens to be 1 as well, right? Then derivative of positive 3 is 0, so I'm not going to write it down. All right, so let's say, raise it to the first power is, doesn't really do anything, so I erase that. And you see that times 1 doesn't really do anything, so I erase that. All right, and here, times 1 doesn't do anything, so I erase there. All right, so it looks a little cleaner there. All right, then we factor out the common factor. All right, so you have two terms here and there, and look for something in common. And you can see that this guy has x plus 2. He has actually two of them, and there's x plus 1 over here. All right, so let's pull out quantity x plus 1. All right, that way I take one of these guys, so I circle 2, right? Then I take this guy, right? So it's there, right? Then collect the leftover terms. So you have another x plus 1 is there from the first term, right? Then you have 2 times quantity x minus 2 is left over, so I'm going to go ahead and distribute. So 2 is distributed to x, you get the plus 2x, right? And the 2 is distributed negative 2, so that's going to be negative 4, right? So that's everyone, right? So we took care of that, so that went here, and we took care of everyone, right? So we're going to clean up a little bit more. You have x plus 1. Right, this one is nice already. Right here you have x and 2x. That will make 3x. Right, you have 1 and negative 4. That will make negative 3. Right, so pull out 3 because these two guys have 3 in it. So I'll put 3 right in front. So you have x plus 1. Right, just copy that. All right, so 3 is factored out from 3x, so you have x left. 3 is factored out from negative 3, so it's going to be a negative 1. So you have that. All right, so this is the derivative, and we're going to set that equal to 0 to find a critical number. All right, so this will give you, right, x equals, right, let's see, from here it's negative 1. And from here you get positive 1, right? Then we are trying to maximize and minimize this function over this closed interval from negative 3 to 0. So you can see that this guy is not even on the interval, so we only consider negative 1. All right? Then what we do is we have to look at all possible places that are critical numbers and that are in the interval, and also endpoints, right? So -3 and 0, right? So here are the three possible places. So you have f of -3, right? That's first place, so that's the left endpoint. And also -1. So we have to look at the f of -1, right? And also here, it's the right endpoint would be 0. So we have to look at the f of 0. Right, so let's compute that. All right, f of 3, right? So that's the left endpoint, and just plug it in. So it's a -3 minus 2 is -5, right? Times -3 plus 1 is, so -2 squared, right? Then you have plus 3, right? So this is going to be, all right, so that's 4 times -5 is -20 plus 3. So it's going to be -17, right? If you plug in -1 into the original function, you have -1 minus 2 would be -3, right? -1 actually, plus 1 is actually 0 squared plus 3, right? That's 0 plus 3, so it's going to be 3, right? If you plug in 0, you will have -2 times, right? 0 plus 1 is 1 squared plus 3, which is -2 plus 3, so it's positive 1, right? So you can see that the largest value would be 3, positive 3. So this is the absolute maximum, right? So this is the absolute maximum. And the smallest value is -17. So this is going to be the absolute minimum, right? Right? So that's that. So basically we look at the endpoints of the interval and the critical number inside it, and find all the function value for each, then pick the smallest one as the absolute minimum, pick the largest value as the absolute maximum, right? This method only works when you have a continuous function on a closed interval, right? Then you try to maximize and minimize on the closed interval, right? That's it. I hope that this was clear.